So today's topic for our lecture is related to propeller shaft. So for that, I will share my screen. So first, this is related to introduction of propeller shaft. So propeller shaft is connecting the drive from gearbox to final drive. Hence, it is also called as drive shaft, as it is connected from gearbox, and from gearbox is rotated with the help of engine. So from engine, basically power is coming from the engine towards the gearbox, and from the gearbox it is connected to the uh, drive with the help of this propeller shaft. Or if we say in another term, it is the group of parts connecting the transmission with the drive wheels. It consists of propeller shaft, also called drive shaft. Universal joint is also there. Constant velocity joints are there, and slip joints are also there. If we see what is meant by shaft, as this has to withstand torsional loads, it is usually made of tubular cross section. Okay, tube-like structure is used for making this propeller shaft. If we cut that shaft and if we observe that shaft, then cross section may be tube-like cross section. So it is called as tubular cross section. It also has to be well balanced to avoid the whirling at high speeds. So as tube is provided, so hollow part is there, and in this way the whirling is avoided. In this case, shafts are made of steel, aluminum, or composite materials. So large number of varieties are available for the materials of this shaft. Universal joint, one or two universal joints depending upon the type of rear axle drive is used. The universal joints account for the up and down movements of the rear axle when the vehicle is running. Okay, so as the vehicle is running, lot of fluctuations are there or movements are there. So to compensate that, this universal joint is provided. Slip joint, depending upon the type of drive, one slip joint may be there in shaft. This serves to adjust the length of the propeller shaft when demanded by rear axle movements. If we see the diagram, this is the propeller system. So on the left side, engine is provided. On the right side, this axles or this rear drive or drive box is provided. Okay, so this is the front view. If we cut or if we not consider the load body and the cabin, and if we not consider the wheels, okay, and if we only see the cross section view of this propeller system, then it consists of engine, and which transmits the rotation towards this propeller shaft and towards the rear axle. And from this rear axle, here drive is provided at the middle portion, and from bevel gear, it transmits the rotation towards the 90-degree towards the wheels. Okay, in this way transmission takes place. Here these joints are universal joints. If we see the components of propeller shaft, lot of components are there. Okay, so these are the snap ring, then roller bearings are provided. Okay, again snap ring, then universal joint assembly. So all this universal joint is connected with this all this component, and it makes the joint. Then cork material is used for making this gasket. Then slip joint, spline is provided. Propeller shaft, actually this is called as propeller shaft. Then roller bearing is provided to support that shaft. Snapping roller bearing, other oil seals provided, flange yoke, the nuts, U-bolt, lock plate, journals. Okay, then this dust cap is provided. Again, here all these parts or components are related to propeller shaft. The propeller shaft is used as a driving shaft to join the output shaft of the gearbox with the differential unit in the rear axle. Okay, so rear axle and gearbox, in between this provided the propeller shaft. The rotational motion of the gearbox main shaft is transferred to the differential unit for rotating the drive wheels. Mainly torsional loads acts on the propeller shaft. Hence, it is made of tubular cross section. To prevent the turbulence generation at high speed, it is perfectly balanced. Universal joint is provided to transmit the power at changing angles of the propeller shaft while vehicle is running. Slip joint is provided with the propeller shaft to take care of increase in length of propeller shaft while vehicle is in running condition. Propeller shaft take power from the gearbox output shaft without making any change in power. It transmits the same to the input pinion of the differential unit, from where the power is transmitted to the drive wheel through the rear axle. Okay, so first rotation comes on the pinion, which is having the small in size, and after that it transmits the rotation towards the wheels. To accommodate the change in line and level between the gearbox output shaft and differential input portion shaft. If we see the constructional details of propeller shaft, the propeller shaft used to transmit the power from gearbox output shaft to differential with tubular cross section, and one or two pieces of piece construction is also there. The two-piece propeller shaft is supported at the center by rubber mounting bearing. Okay, here it is called as two-piece propeller shaft. It is the support is provided at the center, and here the material used for the support is rubber mounted bearing. Next is propeller shaft should be rigid enough to absorb the twisting action due to driving torque and the torsional shock. It should be capable of resisting the vibrations. The tubular propeller shaft is generally used because the reasons are it weight less. The weight is less because it is hollow shaft, so material is less, and in this way the overall weight of this propeller shaft is less. It can resist misalignment. So as misalignments are also occurs, and that misalignments are avoided by using this arrangement. U joints are provided and shaft is provided, and in this way the misalignment should be avoided. It has good torsional strength as hollow shaft is provided. In case of hollow shaft, torsional strength is high, so tubular shaft is good. It provides less resistance to change of angular speed caused when hook type coupling is used. Okay, so here change it gives the resistance to change of angular speed. Propeller shaft is running faster when overdrive is used. Hence, it should be produced as per required design specification and good limit of balance. If we see the vibrations in propeller shaft, the vehicle having bigger wheel base need long propeller shaft. Long propeller shaft generated whirling by bending at its center. Okay, so if we use the long vehicles, then in long vehicles, the distance between engine, gearbox, and that rear axle is large. So in this case, we required the length of shaft is high, and in this way, if the length of the rod or shaft is high, then bending may occurs, and the bending should be at the center location. In such condition, resonant vibrations are produced in the body. Hence, along with whirls, vehicle body also vibrates. What is meant by resonant? Resonance means if the component frequency matches with natural frequency, then resonance occurs. So in this case, propeller natural frequency and the components frequency if match, then resonance occurs. So in this case, the resonance vibrations are produced in the body. For resonant frequency of propeller shaft, there are two groups of main factors producing the vibration. The factors related to propeller shaft and factors related to vehicle body. Factors related to propeller shaft, these all the reasons related to vibrations of propeller shaft. So factors related to propeller shaft, that is shaft diameter and length. Okay, the vibration depends on the shaft diameter, and length also important. If the length is maximum, then vibrations are maximum. Balancing of assembled shaft and joint, bending resistance of the shaft, all these factors impact on the vibrations of propeller shaft. Factors related to vehicle body, that is shape, how the shape is there, and due to that shape also vibrations occur. because natural frequencies of that shapes are also different, and if that natural frequency matches with the propeller shaft frequency, then the vibrations occurs. And types of body structure, location of body structure parts, then engine transmission mountings, springs, bushing, and panel insulation by clamping quality for drive shaft vibrations. All these factors affect the vibration. Shifting of center of gravity is also responsible for vibration. Bending of shaft at the center, irregular thickness of wall of shaft tube, all these reasons related to vibrations. By rolling from flat sheet, the shaft is produced finally by welding. The welded portion may not have weight same as that opposite metal. The joints of yoke and pinions are at one side of the axis. The clearance of splines shaft is allowing shaft to shift towards one side. If we see the propeller shaft structure, the different types are there. So this first type, that is torque tube drive. Here, this is the gearbox. Then this is called as curb, and from that curb, this is the joint, and this is the propeller shaft. Again, this is the universal joint, and it transmits the rotation towards the rear axle. From rear axle, the rotation is transmitted towards the wheel. This is the leaf spring. This is shackle, which is used to connect the leaf spring with the help of that frame, and frame is called as backbone of the vehicle, and all the components are attached to the frames. So our concern is related to this torque tube. Okay, as the cross section is tubular like cross section, so this is also called as torque tube drive. In this case, the propeller shaft is enclosed in a hollow tube. The tube is rigidly bolted to the differential housing at one end and is fastened at the other end to the transmission through a somewhat flexible joint. Universal joint is situated in spherical cup fixed to the frame. The torque reaction and driving thrust are taken up by the torque tube. When the vehicle comes across a bump or shocks, the center line of the bevel pinion shaft will not be shifted and always passes through the center of spherical cup. Again, in this case, hence only one universal joint is required at front end and no universal joint at the rear end in this torque tube drive. The tube incorporates bearing which support the propeller shaft. It is usually located between the transmission gearbox and the propeller shaft. No sliding joint is required in the propeller shaft. In this drive, the leaf springs takes only the side thrust besides supporting weight of the body. And second type of this propeller shaft is Hotchkiss drive. Hotchkiss drive, the diagram is again same. So this is the Hotchkiss drive. And if we see the detail, the Hotchkiss drive is simplest and most popular form of rear axle suspension. Hotchkiss drive combines the springing and positioning or locating of the rear axle. It uses a rigid axle with leaf spring mounted at its extremities as far apart as possible on the rear axle. The Hotchkiss drive consists of a leaf spring and a propeller shaft with two universal joints and one sliding joint. The front end of the leaf spring is pivoted in pin of bracket which is bolted to the vehicle frame, while rear end of the leaf spring is supported in swinging shackle with anti-friction bush material. The leaf springs are bolted rigidly to the rear axle, casing at the middle. The spring takes weight of the body, torque reaction, and driving thrust. Okay, the spring can take the weight of the body. Okay, all the weight which is coming on the spring, and it transmits that weight. And torque reactions are also there, and drive thrust is also there. Then in this case, the driving and braking torques are absorbed through the front half of the rear leaf spring shown by dotted lines. During the driving and braking, the bevel pinion changes the position, so the length and angle of propeller shaft changes, which will be adjusted by universal joint and sliding joint. Therefore, if only one universal joint is at the front end, then the propeller shaft may bend or damage. To avoid this, another universal joint is provided at rear end. When the vehicle comes across a bump or shocks, the rear axle moves up and down and it has to move in a circle with front spring supported at the frame as center. During this movement of rear axle, the length of the propeller shaft changes, which will be adjusted by sliding joint. If we see the next component in the propeller shaft, that is universal joint. A universal joint allows driving torque to be carried through two shafts that are at an angle with each other. A simple universal joint consists two Y-shaped yoke, one on the driving shaft and other on the driven shaft. So two universal joints are provided. The four arms of spider are assembled in needle bearings in two yokes. The driving shaft and yoke force the spider to rotate. The other two trunnions of the spider then cause the driven yoke to rotate. When the two shafts are at an angle with each other, the needle bearings permit the yoke to swing around on trunnion with each revolution. If we see the diagram, this is the universal joint. This is the actually shaft. Then this is yoke. This is again yoke part, second yoke part. Then cross piece is provided, and this is again the shaft. So from this, okay, on the left side, if we consider the gearbox are there, so this is actually connected to the main shaft of the gearbox. From the main shaft, rotation comes on the yoke, and yoke is joined with the help of this cross piece. As the yoke rotates, this cross piece also rotates, and cross piece that is connected to the another yoke, and this yoke is again connected to the shaft. And on the right side of this shaft, imagine that propeller shaft is provided. So a simple universal joint does not transmit the motion uniformly when the shafts are operating at an angle. Because of these, two universal joints are used in a vehicle, one between the gearbox and the propeller shaft, and other between the propeller shaft and the differential pinion shaft. Constant velocity joints are also provided. So constant velocity joints allows a drive shaft to transmit the power through a variable angle at constant rotational speed without an appreciable increase in friction or play. So friction is avoided in this case in constant velocity joints. They are mainly used in front wheel drive and many modern rear wheel drive cars with independent rear suspension typically use CV joints. At the ends, CV means that is constant velocity joints at the ends of the rear axle half shafts, and increasingly use them on the prop shafts. Constant velocity joints are protected by a rubber boot. A CV gator cracks and splits in the boot will allow contaminants in which would cause the joint to wear quickly. If we see the constant velocity joint, this is the diagram. Then this is the axle shaft. This is universal joint. Okay, then axle shaft outer portion is shown in the second diagram. Then universal joint outer portion, universal joint inner portion is provided. So this is the constant velocity joint. And slip joint is also there. So slip joint is attached to the driven yoke in order to increase or decrease the length of propeller shaft. It has outside spline on the shaft and matching internal spline in a mating hollow shaft or yoke. When assembled, the splines cause the shaft to rotate together while they can move back and forth. This changes the length of propeller shaft. So in this way, we finish these propeller shaft topics. So in overall, we see the different types of propeller shaft, and we see how the rotation is comes from and how the rotation is transmitted to. So rotation comes from the gearbox main shaft towards the propeller shaft, then propeller shaft transmit it to the rear axle. This is the sequence of operation. And after that, we learn related to the types of propeller shaft. So different types of propeller shafts are there. And after that, we see the joints, universal joint, and then different the systems are there. So all we'll learn in this topic. So we stop here. Thank you.